Hi everybody, welcome to this video. In this video I'm going to show you how do I run causal inference or causal analysis to understand the relationship between the metrics, between the variables. If you watched my previous videos about the A/B testing, you watched that how the treatment and group controls can be impacted based on different criteria. But A/B testing, statistical analysis, correlation analysis, all these things only talking about the relationship. But as you know, causation is not correlation. A/B testing and statistical analysis only talk about, okay, if one variable's up, the other one goes up, or vice versa. But causal inference is totally different. Causal inference says if we have some variables or confounders, do they really cause the other variable is impacted or not? Causal inference is talking about the causation, not only correlation. So for causal analysis, first of all, there should be a correlation, and after that we can talk about the causation. In this project, I'm going to walk through two different popular methods in causal analysis. Difference in difference, or DD, and PSM, or Propensity Score Match. I'm going to go step by step, but I'm not gonna talk about the coding, because code is just a way to capture the data or the insight that we would like. You can do even with some statistical software like SPSS or MATLAB or Minitab. I use Python, but more I would like to talk about the results, the interpretation, the plots, or what we captured about this kind of analysis. If you're ready, we can start. All right, let's first see our steps in our project and which steps we are going to do, which kind of analysis. First of all, I'm going to talk about the problem, which kind of problem we are going to talk about, or what is the goal for this project, or these kind of things. This is the basic step. If we don't know the problem, what's the use of doing all this analysis? And first of all, we should know what we are looking for and what is our objective. After that, we are going to talk about the data. We should know which kind of data do we have and which columns are important for us, which column is the treatment or group control, which are the confounders, or these kind of things. We should get familiar with the data, and in causal analysis, getting familiar with data is very important. In other analysis, like statistical analysis, exploratory data analysis, machine learning, all these things, data is important, but in causal analysis, understanding data is one of the most important sections, because everything we're gonna do is coming from those data, and if we select the wrong confounders or wrong variables, all the analysis would be wrong. The next step is that why we need difference in difference, PSM, or causal analysis. Why we are going to do that? Why we are not going to use a simple A/B testing? Why we are not going to use a statistical testing? Why we are going to work on causal inference? So this is a very crucial step, because causal analysis or causal inference is a bit mathematical concept, and it needs a bit higher level of mathematics and statistical analysis compared to other statistical techniques. So it is very important to know why we are gonna do all these not hard, but a bit complex interpretation on data, why we are not gonna with a simple A/B testing. So we should understand why and what's the reason we are gonna use for causal analysis. And the next step is that one type of causal analysis we are going to do is the DED, or difference in difference. This kind of test is used for comparing the result over the time. It means what was the before, what was the after. So this is as a scale, as a trend. when we are going to compare two things all the time, before and after, DED analysis is the best and it is very useful. We are going to do for our analysis in one section. The other one is propensity score matching. This is also very, very useful method in causal analysis because with these techniques, we can understand out of all the users, out of all the records that we have in our data, which of them are totally, truly similar to each other. And in this case, we can understand the treatment group, the control group, we can just shrink them or slice them based on the exact users, based on the similarity do they have. This is very important because in single or the simple A/B testing, we just randomly select, but PSM helps us. These two groups, treatment and control, we are comparing the users, not the random users. Those users are exactly behave in the same way. So this is very, very, very powerful technique to make sure the two groups that we have, they are totally same, or at least they are behaving in the same way. And the last step is that, okay, we have two techniques, we have two analysis, definitely we have many, many results for each. Now it's time to go with business interpretation. What is the final result for business stakeholders? They don't care about all the mathematical things or analysis that we do in our tools. I use Python. As I said, you can use Minitab or SPSS or MATLAB. They don't care. They need, okay, what's the final result? What is the final insight and interpretation? That's very, very important in my every single project. These are all the steps that we are going to do. As I said, I'm not going to go and explain the code, but then I'm going to explain just a bit to review the code, and after that, we jump to the interpretation and the results. Okay, now let's talk about the problem. We have a telecom company as a case for this project. This company just rolls out or launched one new program or one new service for the customers. And they would like to know what is the impact of these programs on churn rate. As you know, churn rate is one of those problems that every single company is dealing with. And this is very important because it impacts on several KPI, like financial metrics or marketing metrics. So this is very important for companies, specifically for telecom companies, because they have many, many users. So this is the case. They just launched a program. It's a kind of loyalty program. And they would like to know what is the impact of this program for customer churn. What is the journey for this project? Let me explain this way. It might be a better understanding. Let's say we have one, for example, a deadline. This is the deadline for launching the project. Let's say, for example, January 1st. This is the time that company is going to launch the program. Every single section before these dates is going to be called pre, and every section after this launching is going to be called post. So the company is doing this way for the data. It says, okay, I have some users, for example, user 1, user 2, user 3, and user 4. Every single of these users are going to be categorized in two groups, group A or group B. Let's go, for example, for user 1, this is control. It means these users didn't receive any program. This user received the program, and this user didn't receive. Now here we have the churn rate. Let's say this is the churn status for the churn for the customer, and also here we have churn. This is after. Let's say before launching the program, this section, these users didn't receive any program, and this user didn't churn. So churn is 0 because the customer is still using the service. But in the post section, after launching the program, even though not receiving the service, this user churned. This user didn't receive any program, but after launching the service, these users churned. So it means for these specific customers, launching the program has nothing to do with the churn. Why? Because these client didn't receive any program. So the question is that why the user churned? So it means for churning, only launching the program is not important. We can say launching the program by itself doesn't cause churn. Or the other case, for example, we have one customer, they received the program. Before launching the program, the users, let's say, didn't churn. After launching the program, this user received the service, and this user didn't churn. And we might think maybe receiving the service helped the user to stay. But let's see the other example. The other example, these users didn't churn. After launching the service, this user received the program and she churned. This is one case. And the other case, we might have one user churned even before launching the program. And just because it churned, definitely the post should be churned, because this is impossible. Somebody churned, and after that, the receiver not serviced and she doesn't churn. So if some clients churned in the pre and post, they should definitely churn. This is some kind of context behind the scene. What kind of problem we are gonna deal with this scenario. We have two techniques in our project, DED, which is gonna compare these sections, churn for these sections, between churn and not churn, for control and treat, with the previous one, before launching. We are gonna make sure to understand the relationship. Does it really launching the program causes for churn, or there are some factors? But PSM is gonna talk about the customer's behavior. For example, PSM can say for these users and these users, as you can see, they are in two different groups. One of them is control, one of them is treat. But both of them churned after post. And maybe they are similar in other factors. For example, like demographic or services, variables, other features. They are behaving, they are using the services in a same way. So this is some kind of PSM method can help us to understand this issue. We are going to apply these two techniques to solve these important problem for the company. I just talked about the problem and which kind of approach should we have for this project. And now we can go and take a look at the data. Okay, now it's time to take a look at the data. The data that we are going to work is just a data from the telecommunication company. We have some columns. As you can see, one column is the tenor. Tenor in months, it means how long the user has been receiving our services. This is one factor. The other one is monthly spend. How much a user is spending the money for the services that she's receiving from us. And the other one is number of the complaint ticket, because in telecommunication industry or the SaaS company nature, a number of the tickets is very important, specifically number of the tickets about the complaints, because it means how satisfied they are about our services. All these metrics, all of them are categorized as a confounder. Why confounder? Because as you can see, none of them is talking about the program that the companies just launched. And they are other factors. So these factors might be impacting on the relationship between the program, launching the program, and the churn. So these are is called as a confounder. The other one, I just select these ones. They are confounder. The other one is some other columns. We have loyalty scores. This is just one column that in this project, I'm not gonna work on that. This is RDD, another Causal Inference, but you can totally never mind about this column for this particular project. The next column is about the treatment that you are familiar with this column. This column is just talking about which kind of group a user falls. For example, binary. 0 means the user is in a control group, and 1 means the user is in the treatment group. This is about the loyalty program. The other one is about the post or pre. If this is 1, means this is after launching the program, and this is 0, it means this is before launching the program. And for every single user, as you watched earlier, users, all of them must have 2 versions, pre and post. But every single user must only fall in one treatment, 0 or 1. But for post, they must have 0 and 1. But with different confounder variables. For example, maybe after launching the service, they are spending different monthly, or definitely this is different tenor, because at least, for example, several months after pre, we have post, so the tenor increased, and this kind of metrics. And the last one is just the churn, our target, whether the customer is churned or not. These are all the columns that we have, and as you can see, we talked about these sections. I just gave you an example, what is the treatment, what is the pre, what is the post, and these kind of examples, we talked about it earlier. And this is just the code that we can take a look at the data. I just wrote with pandas to read the data. If I open the Excel, it might be even better for you to take a look at the data. For example, for customer ID 0, I just drag these sections. You can see this customer, for both sections, for both of them, this is 0 in a treatment group, for post and pre. But this user must have 2 sections, pre and post. User number 1, pre and post. User number 2, pre and post. Every single of them must have 1 section, pre and post, but all of them should fall either treatment or control. You see, for example, for user number 3 is in a treatment, or user number 2 is in a control group. And they have other metrics, and also this is the churn. For example, user number 3 is a good case. You see, user number 3, before launching the program, this user didn't churn, but after launching the program, this user churned. And this user was in a treatment group. It means this user received the program, and after receiving the program, this user preferred to churn from the company. These are all definitions about the data. And now we are good to start our causal analysis and to see why we are going to use causal analysis for this particular project. Now let's see why we are going to use causal analysis for this project. If I explain this code for you, first of all, we are just going to focus on the post sections. Why? Because this is after launching the program, and we just want to see what is the impact for after launching the program, all factors like confounders or even the launching the program on a churn rate after. So I just slice the data for post, and after that, I just want to find the average for the treatment for how many treatment users do we have in a post section. And this is a result. You can see after 5,000 customers that we have in post, after launching the program, we have 5,000. And it makes sense because overall we have 10,000 records. We have 5,000 customers, each of them in post and pre. So post, we have 5,000. But out of these 5,000, if I split it to control and treat, you can see treat only accounts for 36%, and 64% of post users, all of them are for the control. This 64 is counting for just this number, 3184, and this 36% accounts for 1815 users. But if you can see here, we have churn rate. This churn rate, what does it mean? This churn rate means if I consider all these 64 as, for example, one data frame, and the percentage is 100% because all of them are post, and in a control group, we can say post and controlled. All of them, out of this number, almost 40% churn, which is coming from these sections. But what about the treatments? The treatment, we have, again, the treatments, all of them are post, but they are treatment, and 100% if we have all of them. Out of this number, just 28% of them churned. So it means, okay, this is all of the post, and this is post. This is the treatment, the users receive the service. And this is the control, the users didn't receive the service. We can see it was 40% churn. Now it is 28%. I can conclude the difference is almost 11%. So in a very naive understanding, without any causal inference, I can say that's amazing. Loyalty program decreased the churn rate by 11%, which is amazing. Let's make a celebration because the launch program decreased the churn rate. But this is very naive understanding. Why? Because we have some confounders variables. Even though the churn rate decreased, we can't say only launching the program cost. Maybe there are some factors that we should think about it. Now let me explain why we are gonna just doing the causal inference. As you can see here, when the company is going to put the users in a treatment and control group, they didn't do it randomly. They launched the service for some users based on some factors like tenure, monthly spend, and number of the complaints they have. It means unlikely to A/B testing that randomization the user selected just randomly put in treatment and control. For some cases like these cases, the company is not gonna randomly choose the users. This situation might lead to bias. And because they choose the users based on some factors. Let me explain in details. The factors that I'm talking about one of them is tenor. The tenor is one factor. As you can see here, the treatment, which is the yellow one, as you can see, most of them, if I just draw a chart, it's gonna be like this way. You can see from these sections, all of them, the tenor is so high. It means the company is putting the users who have been receiving the service longer than other users for putting in a treatment group. So it means we have bias. And as you can see, for the other sections, for the control starts here and it's almost down here. It means the control ends here, but the treatment ends here. This section is a difference, and this section is a bias. And simple A/B testing, or the simple comparison that I just showed earlier, those 11%, is not useful because we totally ignored all this bias. And as you can see, all these two group treatment or control, all of them are just have overlap in these sections. So those A/B testing or the simple comparison only works for this area. But it totally ignored these sections. All these sections, all of them are biased that we should think about it. What about the other one? The other one is monthly spend. Again, the company is just applying this service for those users having the monthly services. The control group ends here, but the treatment ends here. So we have some kind of bias here. And this is just a common area. Again, we have some bias. Also for number of the complaints, the company only puts those users on a treatment that they have less number of the complaint. And as you can see, if number of the complaint increase, we don't have any treatment. We don't have any treatment. We don't have any treatment even here. So it means putting the user in a treatment group is totally biased. And the company intentionally puts the users for a treatment to receive the service based on a less number of the complaints. All these things, all this bias, tell us putting the users in treatment or control group is not randomized. So I cannot run the simple A/B testing. Simple A/B testing, one basic assumption, if you watch my previous videos, is talking about randomization. And randomization here is not allowed. It makes sense. In some cases, companies going to do that. It's totally fine. We have other techniques, which is called causal inference, for solving this kind of issue. And yeah, this is why we are gonna use the causal inference for this particular project. All right, now it's time to go for the first analysis, which is DED, or difference in difference analysis, which is one techniques for causal analysis. DED is useful when we want to see the change over the time. For example, before, after, last year, this year, these kind of things. And as you can see in the formula, it is mentioned directly. It means we are just going to compare two things. This is the main goal. What is the impact for the treatment compared to the impact for the control? But inside each, we are gonna compare what is the post, what is the pre, the difference between these two. Also for this one, what is the post what is the pre. So for each of them, we have a difference. We have difference here. We have difference here. And these two are going to compare together. And it is called DED, or difference in difference. So for doing difference in difference, there are some techniques, and we are going to go all of them. The first one is just a manual. Just manually, we can just simply just calculate with Python code. Just capture this number, we can subtract, and after that the same for pre, and then we can find the difference. But we know that these kind of techniques have some bias, and it's not very reliable. The other one is that we can use the OLS, which is ordinary least square, which is going to work based on OLS techniques. And this method has two things. For this method, the one way is that, like the other way, we can go with no control, or it means no other variables, no other confounder. Or one way is that with confounder, or yes, we are gonna involve confounder. So OLS is gonna do in two sections. And the last technique is the most rigorous one, the most powerful, is two-way fixed effect, which is gonna work based on a linear model. And it includes all confounder and the relationship between other variables and find the causes they have. So we are going to work one by one to see what we capture. First of all, let's go with the first one, which is just a manual. As you can see here, I just manually find the difference by grouping the treatment for the post and also for the pre. Then I can compare these two. And finally, I plot the result. Let's take a look at this data and the output for this section, which is a manual calculation for DED without any confounder. Okay, this is the result. And as you can see here, we have some data. We have the post churn average, and we have the pre-churn average. For each of them, we have two numbers. We have for control, and we have for treatment. So we have four different numbers, and based on a DED formula, we reach to this number. This is for control, and this is for treated. And the formula said, for finding the final DED based on a manual step, we only need to find the difference between these two numbers. And the result is here. The result is 8%. So it means initially we noticed that without any casual analysis, we said it was 11% less. But now DED, just the basic method DED manual, I can say this is DED manual, we have 8%. So this is one number, this is the other number. Definitely this number disregarded all the confounders, all other variables. Also, this number didn't include those ones, but these numbers include one thing, which is the comparison between pre and post, and which is very one step further that just simply take the post. Because previously we just compared these two numbers, 39 and 28. But this is it. Okay, this is for post, but let's take into account for pre also, and after that make a difference, which is 8%. But this is just the one way, or the first method for DED. Let's take a look at the other method. Okay, we talked about the first one. Now we can go for the second one. As I said, the second one is working based on an OLS assumption. So we have some kind of a regression model. We have intercept and we have some coefficients. And this is very helpful for some kind of further analysis because manual analysis, even though we consider pre and post, but we still have not involved the confounder or other variables. But here we have this ability. So this section is gonna be in two sections, two subsections. One of them is regardless the confounder. It means we are just gonna work based on a coefficient only for the program and for post and for control and treatment. But the other method is that, okay, for post and treatment and control, but I would like to involve the other variables like monthly, spend, tenor, or number of the complaints. So this code, as you can see, has two sections. One, OLS, is only considering the treatment or the client or the user is treated or not in a control group or in a treatment group. This is pre-test or post. It means after or before. And the other one, these two variables, nothing else. But the other method says that churn is not only coming from these three columns or these two columns that we talked about it also includes something else. Like here, we have tenor, we have monthly spend, and we have number of the complaints. So it means churn not only is caused with these things that we saw in a simple model, we also see for impact for other variables. And this is the more advanced technique for OLS assumption. Don't forget, we are still working on DED, before, after, or pre or post, but we are using the other method, which is for OLS, and this is the advanced version of the OLS. And then we can just simply make a function to make a summary or the result. Okay, first let's take a look at the result for the simple version. For the simple version, as I said, we have OLS assumptions, so we have some columns that we would like to work on that. We have coefficients, we have p-value, and we have just a confidence interval. And as you know, we just have the treatment, or this is in a control or treat. It is name of the column. The other one, we have post. It means this is pre or post because post is a binary column. It's not only post, it is name of the column. It might be 0, which is pre, or it might be post, which is 1. And this is the combination of these two as one variable that we are going to work as a DED or the difference. Let's take a look at the values that we have. First of all, you can see for treatment, we have this number, and for post, we have this number. It means adding, I would like to talk about the first one. Adding a users in a treatment control, it means giving that service to the users decreased, because it has the minus, decreased the churn rate. And just because the p-value is less than 0.05, this is significant, and it decreases. Decreased by this number, and this number in the confidence interval, as you can see, confidence interval here, all of them are minus. It means putting the client or the users in a treatment group. It means giving the service to the user, decrease the churn rates. Definitely decrease, because both of them are minus. It means we are in the left side of the scale. But it varies between 0.002 to 0.059. But our number is this number. This is good, so it means giving the service decreases the churn rate. But what about this one? Let's go with the green. For this one, again, it means after launching the service, regardless the users receive the service or not, because this is only talking about the pulse, regardless the user received the service or not, decreased again the churn rate, and this is just the confidence interval, but it has also positive. It means sometimes it increases the churn rate, sometimes it decreases the churn rate. But what about the last one, which is the combination of both? This number. This number says, okay, after launching the service, if you have a user receiving a service, it means this is in a treatment, and also after launching the service, we decreased the churn rate, and it is also minus by 0.08, like the 8%. If you remember, the manual step told us the 8% almost. OLS also tells us the 0.8%. So if I would like to summarize, we can say we have two scenarios. Let's say we have one user, user number 1, in a pre, and we have post. User number 1, let's say this user is in a treatment. It means this user received the service. And just because this is received the service, also here this user received the service. Let's say treatment is equal 1, treatment is equal 1. This user, after launching the service, just because treatment and post, for both of them, treatment and post, we have less chance of churning because this user falls here, falls in this area. But if we have one user like this way, we have user number 2. Let's say user number 2, treatment is 0. It means this is in a control group. So treatment is 0. This is in a control group. But just because these users only in a post, this condition lives in this area, lives in this section. So we might have a big chance even this user churn, because we said here, but still there is a chance of the confidence interval 95%. This is some kind of interpretation that we can have for as a simple OLS, because we have not involved still the other variables. But now let's take a look at the advanced OLS for DED. Advanced OLS, as I said, we are going to involve other variants or other variables like tenure months, monthly spent, and number of the complaints. Let's take a look at the results and what we captured. All right, this time we have more variables. We not only have the treatment, post, and its relationship together, we have some more here. We have tenure, we have monthly, and we have number of the complaint. If you take a look at the data or the coefficient that they have, you can see for the previous one, we have still like the previous that we captured, also for confidence interval. But if you take a look at the new variables or the confounder that we captured, we have some more information, which is great that we can talk about it. Let's say analyze just the tenure months. It means if a user just increases number of the months she has been receiving the services from us or from the telecommunication company, its causes less chance for churn. And this cause falls between this area, which is good because both of them are less than 0. So it means definitely having the tenor months, the log odd tells us, the coefficient tells us we have less chance of churn, which is great. If a user is spending more money, if the user spends more money, it causes churn. Because regardless, this is pre or post, because we are only focusing on treatment. If we have the same analysis for months we spend, pre and post, we have different analysis for this. But these things tells us, okay, for these things, it leads to churn again. It means more money, less to more churn, which is very bad, but we should think about it. Because even it makes sense. I'm a user, I have been receiving the service, but I'm paying more money. So it means perhaps I'm going to churn to other telecom company as my operator. And the next one is number of the complaint. Let me just remove this one. The next one is number of the complaint. It means, even it makes sense, if number of the complaint, if I complain more, definitely I will be prone to churn more. And as you can see, both of them are bigger than 0. Definitely, with 95% sure, definitely they will increase the churn. Okay, you might ask question, why for treatment we have pre or post here, but why for tenor or monthly or number of the complaint we don't have? There's the thing. Our metric, our criteria for our project is only for post, pre or post. And for the treatments, we are not going to work on number of the complaint. For example, we can say number of the complaint before pre or the before launching or after launching. Our case is only for this is in a treatment or this is not in a treatment. But yeah, this is the advanced analysis for OLS, which is linear probability model or linear least square techniques with considering the confounder. Now we can go with the third method for OLS, which is like this one, but it is more advanced. And again, one last thing, still this metric, which is the combination of these two, still this is 8%, which is confirming we have 8% less chance of churn after launching the program, even with considering the other factors. All right, the last method for DD is two-way fixed effect or TWFE panel techniques. It is pretty similar to the OLS Advanced, but one thing is that we add some entity to the model to make sure we are working on all customers level, all the sharks or anything that might happen during the time for the customers. Previously in advanced OLS, we just said, okay, if we involve the other factors, what happens? These techniques similar, but this technique remove all the impacts for the sharks or anything by adding one more intercept. And this is the code. First, we should create a panel, and this panel is just a combination of the customer ID and whether this is the pre or post. And this is just a panel OLS, which is a function, and it gives us just a OLS method and techniques like the previous ones, but it is more rigorous. And now we can just find the results here. Let's interpret the result for this method. All right, This result shows us the difference, only the difference between the treatment and pre or post. Pre or post. We have many data, but we only captured the final number that we have. And as you can see, the confidence interval, it doesn't include any zero. It means definitely we decrease the churn. And as you can see, the number is still 8%. So it means with DED, if I would like to just summarize the DED technique that we did, first of all, without any casual analysis, naive told us just 11% less. DED with the manual, just the techniques, it tells us 8.2%. DED simple OLS, I just say sim OLS, gives us 8.3%. Also, DED advanced technique gives us again 8%. So it means OLS focuses on 8% altogether, which is good. So we can say if we want to see the impact of the launching the new program over the time, with considering the confounder, with considering before launch, after launch as a DED, we can say we definitely can decrease the churn rate at least 2%, at the most 13%. Why I just said left to right instead of right to left? Because both of them, if you see, they are minus. So it means whenever we go to the left, it is the highest decrease percentage for the churn, which is very good interpretation for the business stakeholders. We can say, yes, you can just ship, and launching that program was wonderful. However, this is after launching the program. This is we have post. But yeah, this launching the program impacted on churn rate. This is just a DED based on a pre and post. Okay, now if you want to see the final result for DED, you can see we have manually this number, and all of them are talking about almost the same number here. All of them are talking about 0.08% less chance for churn. And as you can see here, we have some at the visualization. What is the OLS did? OLS did, all of them are the same, but the metric, no effect, no confounder, just the pure OLS. The confidence interval at least 4%. Or here, less than 4%, at the most, a bit more than 12%. For this one, we have at the most the same, but at least we have almost 0.5% with involving confounder. And if we go with TWFE as a panel, which is the best one, because we have more range for the churn, for the highest level, but for lowest level, we might have less chance for churn, but still, just because this is before or this is less than 0, still is good. This is just the manager decisions, how risky they are for making this decision. If they go with this method, we might have highest reduction in churn, but compared to these two, you can see we have here also we have this difference. This is a bit less chance, but still, as I said, all of them are minus. This is just a final interpretation for DED technique. Now we are ready to go with the other technique, which is PSM. Okay, let's see first what is PSM. PSM is one kind of causal analysis, but it is more focusing on only treatment and control group. If you have two sections like a treatment and like a control, inside of them we have many cases, but it is only focusing on some part of the client, for example, only these sections. Why? Because they are pretty similar to each other and they are doing in the same way compared to other users. So it means we are shrinking. We are more making the treatment column or treatment variable more precise in terms of homogeneity. We are just significantly or statistically smaller data, but they are more quality. And how we can find it? Based on a propensity score. So for each and every single user, if we go with the step, we have 4 steps. First of all, for every single user, we would like to find PS score or propensity score. It means how chance every single user has to be in a treatment. It means if you have 10 users, each of them has 1 PS score. And this is telling what is the chance for this user to receive a service or be in a treatment group. What is the chance for user 2 to receive the service? It means being in a treatment group. This is just step number 1. Step number 2 is that, okay, each of them has 1 value, but do we have any overlap? If you have the overlap, this is good. Because it means, okay, there are some users, they have the same PS, they have the same propensity score. It means they have the same chance, almost the same chance. And we have a bit, if I go with, for example, if this is the whole customers or all the users, let's say only this section have the overlap. So compared to the first one, we have a smaller number of the users. But in number 3 says that we are just going to work on a Caliper method. Caliper method, it means not all these ones, even though they have the same chance or the similar chance, but they are not treating, they are not behaving in a similar way. So we are going to shrink it again. We are going to still shrink it. Let's say only this area and only these sections. We are going to shrink and only focus on this area. It means I'm going to remove all these sections. Now we are going to focus only these sections because we have Caliper. Caliper is a method for shrinking the common area. And finally, okay, we have 1 section here. This is our final section, which is great. Now here we have 2 groups. We have control, we have treatment. And now we can just find the percentage for the churn rate, which is the difference between the control and group. This is one way, which is just shrinking the treatment and users based on this. Just find the similar users. They are pretty similar to each other. It means in this area, if we have control and group, we are only focusing on the blue one. Only those users, they have the similar behavior in our data. This is just the understanding what we are going to do in PSM method. We can start with the first step, which is estimating propensity score. Estimating propensity score, we are just going to work on logistic regression and just find the score for each of them. As you can see, first of all, I'm just focusing on those are after launching the program, because before launching the program, it doesn't matter. After launching the program, we want to see what is the impact of the churn. So I just only slice for post is one. It means after launching the program. Then I involve the confounder, because PSM, we want to see what is the similar behavior for different variables, and confounder also should be included. And then, just because we are working on one simple machine learning, we should have X and Y. X is all the confounders, and Y is only treatments. Control, in control, or in treatment group. And then I just scale the data, because I'm going to work on a logistic regression. Data should be scaled. This is linear model. And then I just fit it and just result the data. Let's take a look at the data that what we captured from the propensity score. All right, as you can see here, we have two groups. We have control and we have treated. This is post, because as I said, we slice the data. But each of them, as the average, they have its own propensity score. For this one, the PS is 26 or 26. For this one, the propensity score is 53. But what does it tell us? It means just because these two numbers are pretty far from each other. Also, the AUC is pretty high. It means these data are so different from each other. If you remember the AUC is a chart. If I just draw the AUC, it is the 0.5. This is true positive rate. This is false positive rates. AUC, it says that as long as this number goes up this way, let's say this is the best one, and this is the highest one. The green one, it means it is only for binary classification, because we are using the logistic regression for treated or not as a PS score. So it means the green line make a very, very good comparison. It means this model can understand the better discrimination between these two. Then the blue one, then the red one, and the yellow one is just by chance, randomly. It means as long as this number is so high, as long as we have high number, as we have here, it means the data at this moment in post, treated and controlled, for assigning the users, we have bias. That we know that we have. Because as I said, the company only put users in a treated based on some factors, not randomly. So it means we prove it here that we have some bias in assigning the user in a treatment and control group. And now the statistics shows us that we have some bias. So this is a good way for go with casual analysis, because we don't randomly just put a client or users in a treatment and control group. We just prove it here. We just certified that we are working on a bias separations or sampling for treatment and control that we can use for working on a data as a PSM method. But where this number comes from based on a propensity score. Previously, we assigned the numbers, and after that, we just say what is the difference between the similarity between these two groups, and we said there is a big difference, so these two groups are not still the same. We need to shrink it. We need to shrink and shrink to make the similar users in terms of the behavior with other factors. Okay, the next step is that we should check the overlap between these two groups, between control and the treatment. Okay, we have now two groups based on a propensity score, but in which area we should focus? We cannot go with all of them. Only those they are similar to each other. All right, here we can find the common area or the overlap. As I said, if we don't have overlap, we cannot use the propensity score. We can confirm here that we have some overlap. The treatments are here. You can see the treatment starts here and maybe here. And the control starts here till here. The common area is the green one. The common area is here, only this area. And it starts here and here. It means we are only focusing on only those users. The propensity score is only these sections. This is the first step. It means the common, the area for the support range is this range. And these are almost 99.8% of the users. So overlap looks good. We have overlap, but we need to go and, okay, it said we have overlap, but we need to, out of this overlap, we need to still only focus on those users. They are behaving in the same way, because the propensity score is just a chance for falling in a treatment column, treatment or control. It's not talking about, it's still the similarity in terms of the behavioral for the customers. So we can and we should go to the next step, which is just the Caliper, using Caliper method to cut the users they are not behaving in the same way. Okay, in this step, we are going to work on k-nearest neighbor as a clustering method. As you can see, we are doing many even machine learning model like classification, OLS linear, and even k-nearest neighbors. Because this time we need to classify, we need to cluster the different users based on a different behavior they have. First of all, we should set the Caliper scale. The Caliper is just 20%. It means if two users have similarity less than 20%, let's imagine they are not doing the same way. If they have 2% stochastic gradient descent for the logistic for the PS score, if you have just 20% similarity above, you can consider as the same similarity. And after that, then we have a data set. Here we cut the data based on this Caliper, and then just the cluster users based on a nearest neighbors method. Let's go and classify or cluster the user only in two groups, 0 or 1. Let's see what is the result for this step. Okay, the result is here. The result shows us out of all the treatment users that we have, if you remember the treated users for post, because we are only focusing on the treated, it is 18F15. This is all the treated users. But out of all these users, we only need to focusing on 787 of them. And just because we need two users, we need one user for treatment, one user for control, we need pair of this number. So it means, for example, before we have all the users, here it was 18, 15 as a treated. After Caliper, they shrink to this number. They shrink to 7, 8, 7 treated. And just because we need the same number for control, we also need to shrink the control dataset for 7, 8, 7 for control. Now this is our data. Just because these two numbers should be added, we have this number here. So we have only these data set for working, and now it's time to go with find ATT, or the differences between the average churn here, what is the average churn here, what is the average churn here, and then find just the difference or the ATT. Even here, we can apply the DED, because here we have very, very similar users. But previously, when we did DED, we didn't think about similarity. It was a different technique. But even you have the hybrid method. First, you can do PSM, then DED, or no, you can, like what we did, just go with DED first, then PSM second. It is totally up to you. I prefer to have the two different separate methods. But now it's time to find the ATT, or the differences churn, between these two groups of users who are similar to each other. Let's see what is the result of Caliper before going to calculation for the ATT. First, we can find a standard mean difference. This is not just the absolute number. And if this is less than 0.1, indicates we have good balance. For example, for 10 months, before matching the users, it was a very high range. It means we have some of them very high tenor, some of them very low tenor. We have very sparse data, but we reached to very good number, and this is less than 0.1, which is good. The next one is monthly spend. For monthly spend, before we have a bit sparse and spreaded data, now we have this number, which is again good number. The next one is number of the complaints. From 0.35, we reach to almost 0, which is great. And the next one is loyalty score, the other columns that we have. And last one, we have the PS score. This is the most important one. You can see we almost reached to 0, and we were looking for this number because we wanted to see only the users, the SMD for the score is 0. And even here, you can see for PS previously, just after the logistic regression to find the PS score, between the different groups, we have this number, but now we reach to 0. For loyalty, we had this number, now we are here. For number of the complaint, we were here, now we are here. Also for these two. You can see for all the variables that we have, for all we reach to 0, which means the propensity score and shrinking data is worked. And now we have the numbers that we were looking for. Now that we have the match users for treatment and for control, now we can just simply find the difference. We can find the differences between these two groups based on this code. And let's take a look at the result is here. We can say, we can do it in a two ways. We can go with the manual, just the simple one. As you can see, for the simple, the ATT is this number, which is 10% decrease in churn. It means at this moment for these techniques like DED, if you remember DED, we also calculate ATT twice. One simple without involving any confounder. Again, here we do it. We do without involving any confounder. And then we go with the advanced method involving the confounder. Without any confounder, we reach to 10%. And as you can see, this 10% reach to very high confidence interval. It is 15%, minus 15%, minus 0.5%, and we reach to 10%. And just because the p-value here is less than 0.05, and it means this is significantly important, and this is a very good result that we capture. But again, this is just a simple one, without involving any confounder for seeing the impact for churn rate. Now we can go a step further and find the OLS, and this time again we have two things. We have one section for treatment, tenor, monthly, number of the complaint, and loyalty score. We involve all together, and just because here we don't have pre, post, or these kind of things, because this is only for DED. We're only focusing on these columns, not pre or post. Pre or post is only useful for the DED. This is before and after. This time, even we don't need pre or post. Why? Because we are only working on post data. And that's why we don't need pre at all. Okay, here we have some information as you can see here, and then we calculate if I see the result is here. Result is here. We can take a look at the result. We have coefficient, and as you can see, for the treatment, we have minus. It means if a user receives the service, it decreases the churn rate. Also for tenor months, it decreased, but for monthly, number of the component and loyalty score, it decreases. This is very interesting things. The loyalty scores increase, it increased the churn, which is very interesting things. But the most important sections here for us is this number. Why? Because we are only focusing on treatment here. And as you can see, the range, the confidence interval is here, which is good. We don't have any zero, and the p-value is less than 0.05, which is a good and big red flag for this analysis. It means PSM shows us the percentage of the reduction, not only for all users, but also for the similar users. And this is very interesting things that we captured. All right, now let's see the final result for the project, what we have for stakeholders. Because as I said, we did all this journey to find out the best result for managers. We have some important columns here. We have ATT, which is number of the percentage or anything that for reduction. And we have some method here that we applied. Let's see what each of them tells us. The naive comparison, it is without any casual analysis. Just what is the average churn before, what is average churn after, or what is the average churn for the treatment and control. This is very simple, but it has many bias, and it means we have 11%. Then we did DD for pre and post. It means if we focus on the column which is called post, it can be 0 or 1. If we involve this column, the percentage for the ATT, it is 8%. It means if we consider the pre-launch or after launch or post-launch, we have 8% of decrease. It means these columns, pre or post, causes only 8% for reduction for churn. What about the other one? The other calculations that we got is for PSM. And as you can see, PSM has two methods. The difference one, just for the simplest one, we reach to 10%. It means if we have same user, but no confounder or other variables, we have 10%. But if we involve the confounder or adjust just the regression for other variables, we reach to almost again a bit less, but they are the same. Same user, but with confounder, with involving confounder, we have 10%. And this is just the final result and calculations. Now this is the final plot that we could capture. You can see this is all what I explained. We have just the confidence interval for DED method. We reach to this number. For PSM simple method, we reach to this number, which is almost here. And this number, we reach to almost this number. And now this is the decisions for managers to make it. Which kind of factors they would like to involve. For example, if they would like to only focusing on what is the impact for pre or post. This is the impact for pre or post. If we want to see these ones as a main, the criteria, okay, this is the percentage of churn. But if we want to work on a similar users, we can go with this way and that way. This is no confounder, and this is with confounder. This is just a decision for managers to make it. All right, guys, we saw that how we can use a very interesting topic like causal analysis to figure out what is the causes of the different variables on a target that we would like to work on. You see, this is totally different with simple statistical testing or even with A/B testing, because it is not about the correlation, it is about the causation. I hope you enjoyed this video, and thanks for watching. If you like this video, please leave a comment or like it. Thanks.